So my name is Davi Ottenheimer. My Twitter handle is the same as my name. It's really long to prevent people from tweeting too much. I'm the Senior Director of Trust at EMC, and I'm going to talk today about Hadoop security. So let me give you a couple introductions. First, a little bit about myself. So from 94 to 2004, I did a whole bunch of different security stuff. Kind of dates myself, but I've been doing this for 20 years. And it was really interesting, but I ran out of space on the slide. So in 2004, I really started working in a bunch of different industries. Like NASA was interesting because they were putting robots on the planets, and they had to do a lot of really cool stuff with the robots sensing and working around data. I worked in astronomy a bit. Before that, West Marine was a large retail company, dealt with huge amounts of customer data and protecting that. Yahoo, of course, we had billions of devices. We had 2 billion users when I worked there and had to work. I was in charge of security on mobile devices, on digital home televisions, that sort of thing. We pulled in a lot of data. BGI, anybody heard of BGI? Barclays Global Investors. It was the world's largest trust fund manager, $2 trillion. Went out of business in the crisis. Well, it got bought, turned into BlackRock after the big mortgage crisis. But in the time I was working there, they sucked in more analytic data than anybody, and they had a bunch of PhDs that sat and mined the trends and did quantitative analysis to figure out where the market would go. So all we did was basically build big data environments for them to predict how not to go out of business, which didn't work. And then 2008, I worked at ArcSight, where I was in charge of compliance. I wrote some of the tools that allowed people to be compliant by looking at all of their continuous monitoring data. 2009, I spun off my own company called Flying Penguin, and I ran that for a few years before EMC acquired me in 2013. Sometimes known as Flying Penguin because of my company, but I'd been running that for about, I guess, almost 20 years, since 95. I wrote a book called Securing the Virtual Environments, which made me really ambitious. I thought, wow, if I can, because I started working with virtualization in 99. And so by 2012, I thought I would just tell people what I had learned, how to make secure or cloud environments secure, how to make virtual environments secure. And then I wanted to write Securing Big Data with the ambition from my first book, and Wiley was my publisher. They kind of suggested I continue on. And I realized pretty soon after starting it that even though I had a lot of background in these big data systems, you can't secure big data. So that's what the talk is about today. I'm trying to be brutally honest because I feel like a lot of distributions, being distribution companies, they want to sell you on this technology. The same way PC manufacturers wanted to sell you on distributed computing in the 80s. So we're right around like in maturity scale of 1988, 89 PCs, where if you connect it to the internet, you're pretty much done. So it's the air gap thing of the 80s we're talking about with Hadoop again, and I want to avoid some of the same mistakes, so I'm trying to put it in perspective of, if we're honest about this, we can start to fix some of the major issues with Hadoop. You talk to a distribution company and they'll tell you, hey, we're doing great things, which is true, they're making changes, but reality is quite different. All right, so this is basically what I do as Director of Trust. People ask me what a funny title, what's my job? Really what I do is try to help people understand how to create trusted systems. And for me, it's boiled down to 3 things. After a year or so of going around the world talking to people, all companies of all sizes, I'm trying to find ways to get more transparency so people can see the risks they have. I'm trying to help build relevant tools. So like my virtualization book was basically saying a lot of these old concepts are good, but you need new tools. APIs are more important than ever. Management console is more important than ever. So use the right tool for the job. Firewalls don't do you much good if you can't see into the networks behind the virtualization layer. Same in big data. You have a firewall around your big data environment, all the risk is inside. It doesn't matter if you have a firewall, really. And then resilience seems to matter more than ever before. So people just don't trust systems if they go down. People expect an always on, always ready, always accessible environment. So that's pretty much what I do. And I always run into this dilemma now, which I call the Sam Jackson audience dilemma. So it basically breaks down to 2 parts. You're either a one more timer or an umption. Anybody know what I'm talking about? All right, so the one more timers are, stop talking to me about big data. One more time, I'm sick of hearing about this. I already know everything there is to know. Just give me the really hardcore technical details and I'll get out of here. The others are, anybody know this movie? This is another Sam Jackson movie, kind of obscure, 96-ish. Well, he says, you know, everybody knows when you make an assumption, you make an ass out of me and umption. So the idea is either like, don't make any assumptions, tell me everything. Explain to me how MapReduce works, or I know everything, and it's like hard in the big data world. So how many people here run Hadoop environments themselves, have set up and run Hadoop environments today? Okay, just a couple of people. And then how many people have successfully entered a Hadoop environment somebody else set up, used it, run a job? A few people, okay. So I can't make too many assumptions. I do have a ton of slides, so I have like 100 slides, and it does not include how MapReduce works. So as a quick intro, basically what MapReduce does, the concept of Hadoop is just distributed computing. It's to make jobs easier by reducing load to individual components. So if each one of these rows, for example, was a resource, I would ask the person on the end of the row to count the number of people in the row with glasses. Then I would go through and say, all you people at the end of the row, give me your count. That's it. So I've now basically mapped this whole audience into rows and then asked each head of row to give me the count, which saves me a lot of time. Even better, I can ask the person at the front of the row to map all the counts from the head of the line. So now I've just got 2 people to talk to that give me the results from this entire audience. Make sense? That's MapReduce. All right, that's Hadoop. So let me tell you a little bit more about where it came from. So in 1996, there was a guy talking about how he could take a 24-node Beowulf cluster and he could make the equivalent with $60,000 of a $10 million supercomputer. This was the genesis of Hadoop. This is where it came from, Beowulf. And it was called Beowulf because in the Beowulf poem, this old Celtic poem, the poem actually says, the translation, I think it's Danish, 30 men's heft in the grasp of his hand. So Beowulf was so powerful, he could do about 30 men's work by himself. And that's the whole idea, right? So it's been co-opted quite a bit by Google, and a lot of other people try to take credit for what Hadoop is. Really, by 2006, it became open, so it doesn't really matter where it came from. But the genesis is people trying to do great things with a little bit of money. And so today, we don't talk about it the same way. Anybody remember what RAID used to mean? Redundant array of inexpensive disks? Right? Now it's independent disks because no one cares that they're inexpensive. All disks are inexpensive. Same thing with Hadoop. It's low latency, fault tolerance, and scalability. No one talks about how cheap it is anymore because all distributed computing is cheap, essentially. We've been in a race to the bottom, and commoditization helps. So we're looking for low latency, fault tolerance, and scalability. What I'm here to talk to you about today is how there's latency, there's a lot of faults, and it doesn't really scale well because of limitations, a lot of risk. Like building a perimeter. If you build a castle wall, you can't scale much because as soon as your town is outside your castle wall, you have to build another castle wall and another. And cities today of 20 million people can't be sustained by the castle model, right? So that's sort of the problems we're running into. All right, so here's today, data lake definition. We're moving away from big data as a term and towards data lake. The idea is you have streams of data all pooling into this thing and then you do analysis. I don't like the 3V definition, which Gartner came up with in 2001, mostly because I'm not a huge fan of Gartner, but also because I've been trying to stick the 4th V in for a couple of years and no one will let me. So the 4th V for me is vulnerability. And it just didn't make a lot of sense to people. I was trying to say that if you have so much data, it becomes vulnerable, that then you know you have big data. So now I think it's more popular to be called re-identification, which is if you have so much data, you can be re-identified, then you have big data. So for example, you tell people you can't have a zip code in your data because that's sensitive, or a birth date. It's been proven that above 80% of the time you can re-identify people if you have just one little data point beyond. If you have 3 total, but you have 1 that's sensitive. So you pull out your zip code or your postcode or whatever you call it, wherever you live, and then you also have in that data set the name of a doctor. So the name of the doctor, of course, is somebody who works in a particular zip code or postcode, so I can re-identify people by figuring out where the doctor works, right? So now if I know your doctor, I can just simply one step away with another data set figure out the same thing you were trying to prevent me from knowing. So if I add enough databases and enough data sources, at some point I can re-identify you, and that's when big data becomes big data because you have that re-identification issue. I call it the 4 Rs. I came up with that on Talk Like a Pirate Day, so it's not just by coincidence. So by 2017, the prediction is by most people it's going to be the norm for data management because, again, commoditization, like it's becoming less expensive, a data lake, it's consolidated. Who doesn't want centralized and cheap, right? This is the future of technology. And so let me give you a couple of cool examples. I'll just go through these quickly that I'm working on just to give you a sense of how powerful big data is becoming. I'm working on a clear water project where 1/5 of the water in the world, the water that's fresh water, comes from the Amazon. It turns out that a lot of it's being polluted by things like petroleum and digging. So if we could put sensors out there, if we can map all the places in the Amazon that water is being contaminated, and then we can monitor it and then restore the quality of the water, we can make a huge impact. And how do you do that? You have to put sensors in the jungle, and you have to, within 24 hours, test the water because the water degradation. And then we have to pull it in and keep it safe because there are a lot of pressure points for people to corrupt the results, right? People want to make sure that your results don't say what you think they should say. So that's an example. Here's an example of a group that's trying to reduce orphanages. I worked with them recently, not directly, but indirectly. They're trying to figure out why there are so many orphans that still have parents. Why can't the parents become more sustainable families? And so we need to put sensors out. Again, very politically charged subject. So how do I collect data in remote villages about orphanages, have volunteers? So it's like a distributed problem of data collection to solve a major risk issue. And I'm actually interested in this. I don't know if you know, but a lot of orphans end up doing strange things like suicide combat, like suicide bombing missions, and they end up getting recruited into military conflict and strange things. So we want to get the level of orphans down by understanding why there's so much conflict. Another interesting project I'm working on, United Nations War Crimes Commission. We had 49 trials in Nuremberg and Tokyo, 208 trials around the time at which post-Cold War, we did Kosovo, for example. Turns out from 43 to 48, there were about 2,000 trials that were secret, and they've just been uncovered. So if we can get that data in, mine it, and then provide that resource to lawyers, then they can actually do, with classification working properly, they can go figure out, what do you do if there's a rape? What do you do if there's a genocidal act? Because lawyers base everything on precedent, and there's very little precedent is the point here. But I can generate precedent, and so big data becomes knowledge. It teaches people, how to make decisions, more informed decisions. So here's some more contemporary examples. Traffic, you want to know where to go and how. Some cars are now telling you what speed to go in order to avoid red lights. Some are telling you how to. The new Volvo tells you how to avoid an accident. It just automatically redirects you every time there's a traffic incident. This is an actual architecture built by Pivotal, which is a big part of EMC. So it ingests all the data and then surfaces these cool graphics so you can see what traffic looks like. Energy, I don't know if you know, but each turbine sensor has a lot of sensors. So this goes back to sort of the IoT model. So we're generating a Library of Congress print collection every month in terms of data, because it's 500 gigabytes per day for each blade. And you can see how many blades are on a typical turbine. Anybody familiar with these turbines? Seen these before? Yeah, if you replace this with a big windmill like you see out here, sometimes they can get as many as 30,000 sensors. Why? Because they're reading in, it's like weather forecasting in the transportation. It's reading in the direction of air in order to figure out which way to turn the blade, just like sailing. So you're trying to figure out the optimal to get the most energy. So tons of data being created by all sorts of sources. This is what you might see at a security conference, which is the RSA model, taking in all of your sensors and putting it someplace, storing it so you can do analysis to find your attack vectors. If you have one, it might not tell you enough, but if you have all of them, it tells you where your threats are, right? So I can just keep going through these all day. A couple funny ones. Here is a social analysis of tweets in San Francisco, and it's hard to see in here, but basically the red iPhone, green Android, you see a pattern where the Android people are on ferries. That's like the ferry terminal and then a ferry path across the city, and the red is scattered evenly across the bay, which to me says rich Apple yacht owners versus poor Android ferry riders, right? So instant knowledge. If you look at the downtown San Francisco area, you see BlackBerry users congregate in a little circle. You see there's sort of like a half circle there. Anybody want to guess what is going on over here in San Francisco? Why so many BlackBerry users are congregating? What's that? BlackBerry office? Close, but not quite. Government? User conference. Oh, I didn't think about that. No, but City Hall. That was my guess. It's some sort of federal building, but that's actually further left, quite a bit further left. I had to get out a federal map to map all the federal buildings. Nope, it actually turns out to be the Apple Store. Twitter asked me how I figured this out, by the way, after I showed this to Twitter, and they were like, can we get this data? So it's public data. I just used a public source. Here's weather. Anybody know what this is? This is a weather mapping system. It's a radar system that tracks. So what kind of storm is this, basically? What's happening here? Anybody know? It's insects. So apparently global warming is creating this insect boom, and so these are mayflies exploding, and there are pictures that are too disgusting to even show you of towns just covered in insects. So this is an explosion of insects one night, picking up on this. So it basically tells you something strange, though. When you have a detection system, you think about security detection, and you get a false positive like this, it throws off your radar. You're like, oh my God, we have a huge storm coming out of the river, which makes no sense. All right, so quickly, any guesses what this is? Which side is random? Looking at that insect, maybe it's a hint there. How many people say the left side is random? How many people say the right side is random? So it turns out the left side is random because of the connections. On the right side, those are insects actively trying to keep space from each other. And so it actually comes from New Zealand, and you can go on this little tour. You take a little boat, and it's the top of the cave. They're glowworms. So you can get interesting things by looking at lots of data. Sort of on the same level, This is the bombing map of London by the Germans. And if you dig down, it actually looks very like non-random, I guess in a way, because it's like, well, you can see even distribution here, but the further you dig down, the more it starts to look random because there are actual very clear lines and patterns. So apparently the Germans had mapped out exactly where to bomb every run. I used to live in London, so I went and looked at my house. It's an interesting thing to do in bomb site. You can do it live. They do this today, actually. So this is San Francisco. This is an insurance company's big data analysis of where the bombs will hit San Francisco if there are terrorist attacks. And so they rank them by severity, red, obviously most extreme. And it goes on and on. So this is what a blast looks like. This is big data analysis of blast radius after a terrorist attack, like which way the bomb blasts go in an urban versus rural area. And then this is what a smallpox infection looks like as it spreads through the Midwest of the United States. That's Chicago and Illinois. And also St. Louis. And so you can imagine they're doing this already with Ebola. We talk about it a lot, but actually these insurance companies are very accurately predicting these outbreaks and where they spread using big data analysis. I could go through millions of examples. This is healthcare. This is the amount of data that's in each ejaculation of sperm. So 31 petabytes a second of data, which is, Google's only processing 20 petabytes a day. So think about that for a second. And actually on that point too, 144 trillion gigabytes of data in human cells. So you can see why, we talk about big data analysis in healthcare, it gets into this like, wow, it's sort of like holy grail of we could really understand everything if we do the math. This is an Ebola prediction chart. They were off. Anybody know why Ebola predictions were off? This is really interesting. So it's called the GDELT project, and it's a guy, he's very ambitiously trying to suck in all the information in the world, all the conversations to try to see where Ebola is first. And he missed it. Well, it was English. It was an English tool, and a lot of the infections were in French-speaking countries, right? So he missed that. So they're adding French. Hopefully the Germans don't have a disease next. But the bottom line here is sort of spooky because if you take this analogy as big data, he wants to literally listen to every single whisper in every corner of every part of the globe in order to predict the next disease. Versus a distributed model, which would be like, hey, why don't you have a conversation with somebody and through a hierarchy, like the actual detection of Ebola went through the hierarchy. So the local healthcare, like the hospital said, hey, we have a problem. Multiple hospitals said they had a problem to the government. The government reported to the United Nations, right? So that's a hierarchical, local, distributed-based system. And this is a top-down, like listening to everything, we'll figure out where it is first. So he was slower than the distributed system, which ironically, he's running on a Hadoop-like environment, which is a distributed hierarchical system, right? So he's almost like answering his own question. He's not running a mainframe. So here's 2009, Google said that they detected flu faster, and their flu project was heralded as, they're 2 weeks ahead, heralded as the future of detecting flu. Anybody follow this? Anybody see this? Anybody know that it was wrong for 3 consistent years? So today we look back on it and go, wow, they really were way off. But it came out as we can predict faster. And it's because this algorithmic accountability has been one of the problems. It's sort of like it's a box, and inside the box things are happening, and we don't know exactly what's happening. So this is the allegory for the problem with Hadoop. You trust these systems, and then they're wrong a lot of times. So here's the audience operating system. Anybody heard of that? The axiom. So if you're on Facebook and you want to run an ad, you want to make sure you're advertising to real people with real needs, not just fake bogus accounts. And Facebook says, they're keeping it down to 5% fraud or something, which is ridiculously good versus other systems that are just open. So they have this audience operating system type analysis to prove that somebody is real. But then if you go and do analysis of the data, this is a woman who looked at her own data and she challenged it and said, I can't possibly be 26 years old with 2 children who are 14 and 17. You'd think that the system would be able to detect that because those are simple numbers, it's simple math. It should be able to know itself, but it doesn't, right? A human has to go look at it. All right, so biologically impossible. Here's a quick quiz on knowledge from the past. So anybody know the disposable diapers story by Arthur Little? You know why we use disposable diapers instead of cloth diapers? So he was able to manipulate the data and then use marketing to convince people it was environmentally better. We use less water. It's like better to put it into landfill than it is to use a towel or a diaper that's cloth. So it's basically a manipulation of the marketing data to prove to people something that basically isn't true. We found since then that people who go back and look at his analysis are like, this makes no sense. There's been a lot of criticism of it, but it's too late. The market's already pushed towards disposable diapers. Frozen Coke, I won't spend too much time on, but basically Burger King had $65 million on the line. We're going to invest. And Coke was saying, wow, all these students are buying this frozen Coke. You probably want to have it in every Burger King. And then it turned out that somebody was paying students at all the local schools to go to Burger King and buy frozen Coke, literally giving them a voucher so that it would turn up the results. So it was totally bogus results. And then finally, bacon, my favorite example, or one of them. Anyone heard of the Beech-Nut Company and Edward Bernays? He kind of invented PR. He invented manipulation of the media and marketing. So the reason we eat bacon today, my argument is, and a lot of people say this is the case, is he was able to control the consent of the masses to eat bacon. Before then, there really wasn't much consumption of bacon, and the pork industry was in decline, and Beech-Nut, who was selling a lot of pork, wanted a way to sell more. So he linked a study that said 9 out of 10 doctors say a big breakfast is good for you to bacon. And then everybody thought 9 out of 10 doctors say bacon is good for you, and then that turned the market. Diamonds are another example. I could give lots of examples. But basically, marketing since the turn of the century has been trying to get data to turn things into knowledge, and then knowledge becomes like big money purchasing decisions. So that's what Hadoop is really doing. Hadoop is giving people knowledge to change everything, change people's ideas, elections. So the scary part, though, is security capabilities of the data lakes are embryonic. This is a Gartner quote, which hasn't gotten a lot of press, but they're basically saying, hey, we're still in the early stages of security on the systems we need to trust the most. And the model that we see a lot is if you store everything, I like the CIA quote, which is, you can't connect dots if you don't have dots. So they store all the dots, and so they can connect them. And if you can do the right analysis, which could be trying to convince people to eat bacon even though it's bad for them, by telling them it's good for them because some doctor said so in the analysis, that's winning. That's winning the marketplace. So you can build the right tools for the right people and get them to use it. And it's all based on this idea of analysis being like looking in the rearview mirror. And I find that funny because when you look at the rearview mirror, anybody know where it was invented? Big hint here. Race cars. So the first rearview mirror was the Marmon Wasp in 1911. So it was in this Indy 500 race, and the guy put a rearview mirror on because he could get rid of his passenger. The other guy used to look behind. It was a mechanic, basically, and who'd look behind at the cars coming. In order to win the race, you got to know where the competitors are. So the rearview mirror was a winning tool. It was a way, just like we're talking about Hadoop. It's a way to win everything, the market. But I looked really at the idea of race cars, and I thought, wow, okay, so if Hadoop is this giant, powerful engine that makes us so much more powerful, then is there a risk situation like in race cars where if you lose control, you lose everything? And it actually turns out to be true. We blow up a Hadoop environment, it's pretty devastating if you put a lot of trust in it. So this is a real picture of a guy getting thrown out of his race car. He was only bruised, but they started to put seatbelts in the races eventually, and it took about 45 years to go from rear view mirrors to seatbelts. So I'm kind of curious how long it will take us to get from this rear view mirror Hadoop to the seatbelt Hadoop, right, where we actually protect data. And if I look at the seatbelts, it turns out from 1885 to 1970, or really 58 when they first went into use, there was quite a bit of time. And the turning points were criticisms of engineering. So what we really need is the equivalent of criticisms of engineering in Hadoop. Like criticize Hadoop and talk about prevention as the only cure for bad Hadoop, right? So these two articles seem to be that a lot of people think seatbelts are just because of regulators. But regulators got the idea from people pointing out how bad things were, and those turned out to be doctors. So who are the equivalent today of Hadoop doctors? All right, these are the things that Hadoop doctors would be saying. You have immutability by design, so you shouldn't be able to change files, but in fact, you can go and change whatever you want, pretty much anywhere. Happens all the time. And resiliency is by design, but we're finding outages all the time. So even Amazon says, we have an availability zone, but then the availability zone goes down and they say, well, it doesn't mean availability if it's an availability zone. It means you have to connect multiple availability zones if you want availability in your availability zone. And so we get security mode by design. You can turn on Hadoop security. Not many of you have used security, but security literally has like a switch you can flip. And you say, okay, I'm in security mode, but it's not actually secure. Weird, huh? It's like availability zones. And so fractured and complex ecosystems are a problem, and then it's not terribly usable if you're not very technical. It's a lot of Java. In fact, a lot of the tools coming out now, which are like apps essentially, are just so you don't have to touch Java. So it's like apps for apps, because people don't want to deal with it. And a lot of the threat assumptions in 2009 that came out in the original security document were based on no man in the middles, It's really hard to do if you let people into a perimeter and then they have open access. How are you going to stop someone from standing in the middle of a road that's not protected? It assumes that users don't have root. Very difficult to do because the standard Hadoop environment gives everybody root level authority. You have to work really hard to get the levels down. And then there's no NIC control is another assumption, which doesn't make sense. If you already have somebody with root control, of course they can control the NIC. So pretty hard to go with those threat assumptions. The ecosystems are pretty complex. If I was to describe Hadoop to you in a nutshell, what it looks like, this is sort of how it works. You have a storage layer, which I could go into detail after if you want to know how it works. And then you have a compute layer, which is like your PC or any device, your laptop. It's like you have a hard drive and then you have a processor. But it's just distributed over tens of thousands of systems. So you're trying to basically secure the way you would secure inside your machine across a wide distributed network. And then on top of that, you have your apps. And the apps give database access. You can script on top of it. You can stream data. I'll give you a couple examples here in a second. And then on the far right is the security model, which if this looks familiar to the PC model, it's because that would be where the antivirus sits. Like after you've built your entire architecture, now you're going to install antivirus, and that'll be this thing that just takes care of all your security, which turns out to not really take care of your security. And 20 years later, we realized, wow, what a cock-up that was. So there are a lot of projects which are worth mentioning here: Nox, Rhino, Sentry, XA Secure, Falcon, all sort of independent, running on their own. And it's a quagmire of discourse right now of what they're really going to do. So here's an example. Scoop is just like the name implies, scooping data up and putting it into the environment. So that's great. You want to scoop like MySQL database that has all sorts of data, scoop it into Hadoop, make it part of your data lake. The original version was a CLI. People didn't like command line interface, so they made a graphical version and called it Scoop 2, which is not compatible with security mode. So if you want to use the cooler, newer version, you have to turn off security in your entire Hadoop environment. So it's a pretty big compromise. Another example is Storm. Anybody heard of Storm? So if you want to do like really fast analysis of data, like say tweets, you want to see who's following tweets and which URLs are getting really retweeted the most, you can't just do a scoop because that would be static data, and by the time you look at it after processing, who knows how many new URLs are being followed. So Storm is going to stream that all the time, and every time you get an update, it's going to tell you like, oh wow, there's an update. And so Storm essentially does this. It has these spouts and then these bolts. That's a characteristic of Hadoop is really bad naming and really bad icons and like graphics. So spouts and bolts, and it's terrible. But anyway, you use Storm and you can get these real-time updates, and they're really fast. But again, it's designed for, I don't know if I made that highlighted enough. It's designed for scalable, fault-tolerant use of data, right? Fault-tolerant is built in, it's the architecture for fault tolerance because it has multiple services running. But it turns out that it actually fails it's really brittle. And if you do weird things to it, as this one person said, it breaks. And a focus for upcoming releases will be security. So in the future, we'll build security into our fault-tolerant system. In fact, here's one of my favorite quotes. When I can't get it to work, I just do an rm minus rf on the entire Storm directory, and that seems to work to get it started again. Any problems with that in a multi-tenant environment? If you're deleting the entire Storm directory for everybody? Yeah, he says, make sure you only do this in a development environment that you own. Don't ever try to fix, this is the fix, but don't try to use this in a production environment. All right, so let's talk about 7 ways to kill. Hopefully that gives you sort of an overview. We'll go pretty quickly through these. So first of all, I believe, and this is sort of using from Pivotal's model, I believe we should look at it in steps. So you have the ingest step, you're pulling data in, you're storing the data somewhere, which itself is a big security issue. You're analyzing the data, which I showed you can be manipulated into weird results. And then you surface it into these visuals, which of course are suspect to security. And then you take action upon it, which you obviously have to map back to accurate results and security. So my argument is that we should be able to do at least 6 things to protect it. And so I'm writing a book about it, and these are the 6 things I'm advocating in the book. And then the 7th, because I unfortunately named this talk 7 Things to Do, would be GRC on top of that, which I think is important, but this isn't really the best audience for it. So I'll go quickly through GRC. Yeah, I love GRC, but you have to be careful who you talk to about it. So here's an example of zombies versus terrorism. This is an actual honest-to-God insurance chart that I pulled from a big data company. So they're doing over, return period loss by peril. So over 5,000 years, the loss from terrorism is quite high, whereas the loss from zombies is quite low. Anybody know why? Any guesses? Zombies are predictable. Zombies are either zombies or not zombies, whereas terrorists are like everywhere. Any one of you could be a terrorist for different organizations and doing different things, and connections are very fluid. And so the loss from terrorism can be very, very difficult to like avoid, and it's very, very complicated. And this is a personal, to be honest, I changed the name. It's not really zombies, but it's something equivalent to zombies. This is a personal issue of mine. A lot of people talk about the zombie issue in security, in information security, and I'm like, not hard. You either shoot them or you don't. They're either zombies or they're not. It's like the simplest thing ever. So if we're in a GRC mode, going back to my experience with the guys building robots for foreign planets, right? If you have robots that have a little bit of intelligence, then they can do certain things, but ultimately they end up in traffic jams, for example, which we do in our cars, as the police predicted with their synchronicity song. It's like you don't really have enough visibility to know that you're going to run into a traffic jam unless you're in God mode, which Uber actually uses the word God mode. And so they're able to look down and say, we'll route everybody different directions. So governance, risk, and compliance is really about having this up-level view. It's like in big data environments, really having a godlike view to know where you're going to run into trouble. And so we're trying to move away from the simple and the theoretical, the chess game essentially, into the Go game, which is the complex and the real. I mentioned Go and chess because a lot of people talk about Watson and chess and how computers beat humans at chess. Everybody's probably familiar with that. Even your phone can beat you at chess now, very smart. But if you put a Go game on your phone, you should not lose to that Go game. They're not very good. I still lose, so I'm embarrassed to admit that I'm not that great at Go. But I do play all the time trying to win because theoretically I should be beating it. And the problem is that there are 130,000 moves in the first move in Go, but there are only 400 moves in chess. So a lot of our advertising about how cool computers are in these big data environments is directed towards things we win, not towards things where computers fall down. And anybody know what these M&Ms represent? Separating out the brown M&Ms. Anybody know Van Halen? Remember Van Halen used to have in his rider, you must separate out my... So this is basically game theory, where he's like, in order to understand my opponent, in order to win in this very complicated exchange, I have a 50-page, he put up big sets, and there's all sorts of light shows. In order to understand whether they had done any of that properly, he had this buried in there. And if he went to his dressing room and found that they were just brown M&Ms, he knew that they read the whole thing and probably followed everything, unless they were gaming him, which is possible. But because it was sort of a secret and he didn't tell people, he assumed that either they did it or they didn't. And then if he found that it was mixed, he knew that the whole thing was off, and he'd have to go and check everything because maybe things would fall. So it's like avoiding the spinal tap outcome by using game theory with M&Ms. All right, so that's GRC in a nutshell. You need high visibility, and you need to have real threat modeling, which we don't do in Hadoop. We don't threat model, as you can tell. You can't have root. That's our assumption. But of course, everybody has roots. So let's look at some policies like that. Hadoop security, as a policy, oftentimes means access restricted to trusted personnel. And then they try to do this through three things. They do encryption, authentication, and authorization in order to enforce some idea of this policy. The problem being, authentication as an example, we don't do it very well. So security mode, as I mentioned, if you turn it on, you basically move from where you use sudo to run a command to where you run kinit to run a command. If you're familiar with Kerberos, you have to get a ticket before you do something. So in sudo, you have to be in the sudoers file, which is local often. It can be remote, but it's mostly local. So if you move to Kerberos, you're just asking something else for authority. And in big, large distributed environments, that can be a pain. So it can slow things down. So you tend to put tickets in instead of Kerberos tickets. You give tokens that are non-expiring, which I'll talk about in a second. But here, the point really is that if you want to destroy an entire directory, you would just do sudo hdfs as a user, and then the command minus RMR. So file system minus RMR is the same thing as rm minus r in Unix. And so if you turn on kinit, you basically, instead of sudo, say kinit minus k, give me my ticket from the key tab, which sits in the temp directory, by the way, which if you ever work in a Hadoop environment and it starts to have problems, they tend to turn the temp directory into 777 because that sort of smooths things out. And then some of the things that go into the temp directories are your tickets for authentication. So you see the problem starts to compound. So anyway, that's another example is MapReduce job kill. So if you wanted to kill other people's jobs, I see this a lot. You just do kinit if you want to kill it with a ticket. But anybody know why you'd want to kill a job? Well, your job is more important, obviously. So you kill somebody else's job because you don't know what they're doing. Who cares what they're doing? My job's more important, which leads to artifacts, for example. So someone might be running a report, and they'd be like, oh, my job's done early. I'll just run these results, and we'll base our purchasing decisions. We'll buy bacon now because my results show this because someone killed the job early. So, and then if you go to other conferences, like I try to speak at Hadoop summits and stuff quite a bit, and I find the guys that talk about security at those generally say it's a real pain in the. These are the security experts on stage saying this is how to secure Hadoop, and they say it's really hard. So after I've told you these authentication tips, like turn on Kerberos, it's actually really hard. So I don't recommend doing it. But if somebody comes along, like an auditor or a security person, and says, "Do you have security?" then you might want to turn it on. But otherwise, good luck. All right. So here's an example of what I was talking about. Anybody seen Blade Runner? So the concept of Blade Runners, you have these replicants, these robots, and they go away and do things for you, and then they come back, and you don't want them to come back, so you hire Blade Runners to kill them. Well, they're living longer than they're supposed to live. So by default, in Hadoop, you're supposed to have these jobs that live 24 hours or 7 days max. And it's just a simple text file that tells them they can't live longer. And so this is essentially what they were predicting in 1968 with Blade Runner. They were saying, eventually those jobs don't want to die, and they'll try to keep themselves alive. So you have to give people the job of finding and killing jobs, which is what I've seen. And part of it's because you can see the client would get the Kerberos relationship, so it thinks everything's secure and cool. But behind the scenes, your job tracker, which, remember how I was talking about the rows? Your job tracker that's figuring out how to count the rows and assign roles for counting further down, it's actually giving tokens out to authorize all of the distributed nodes to do their job. So the more you're giving out tokens and the more you're spawning jobs, the more you're sort of down the road giving out more and more authentication capability. And so eventually you have jobs running with tokens forever, and you got to go kill those guys. So let's talk about monitoring. Monitoring is a real problem because it's really different on all these different products that you're using, right? Every app is written by a different group. Apache's doesn't have a centralized system or a way to keep track of everything. And then, of course, everyone's got almost root level authority. Anybody recognize this? It's an album cover. Any guesses? I have a lot of hidden stuff in my presentations. This is the Roots. Is it obvious? Do you listen to the Roots? Pretty good band. Anyway, so you end up with a lot of people having root level authority. You can put in other levels of user, but ultimately to run the environment, somebody has to have root and will go in and make changes. And a lot of times I find they give that control to several people in order to keep the jobs running. And again, it's hard. So really, this is an opportunity for me to sort of go off a little bit on how monitoring will change. Anybody recognize this? Yeah, this is lines in gravel. Could be lines in sand. Remember the beginning I talked about the stingray? So can anybody tell which direction somebody's walking here? Anybody do any hunting or tracking? Walking to the left. It's actually walking this way. My right, your left. Yeah, so this is somebody who was walking, stepped that way, and then decided, oops, I'm stepping into a detection system, and then stepped out. And if you ever look at those old Japanese gardens where it's essentially what it's doing is it can tell. Imagine trying to go back and cover your tracks in a sand pit that has lines that have been created by a monk who's been practicing for 30 years. They're essentially setting honey traps, or they're setting traps for you to step into. So this is outside an actual building in Silicon Valley that I was working at, and I noticed someone had stepped into it. So I took a picture. But the idea is this is what we needed to get to in big data. Instead of thinking about it in terms of syslog, like am I reading an individual log off an individual system, I worked a lot with VMware on some of the vCloud security. We tried to move away, and still trying to move away, from the idea that we're just logging this system, and instead looking at the overall view and saying, are we seeing steps in sand? Which gets us to the IoT world too. So if we can actually pull in information from lots of sensors, we don't have to be super accurate in any one sensor. We just pull in change overall. So for example, here's a big data environment where you have like a web server, you have your sales machines, you have your call center, and they start to feed using Flume, which is kind of the fast equivalent of Scoop. In Scoop, you scoop a database in. Flume, you just turn it on, and like your web logs just shoot into HDFS. So if you're pulling all of your logs basically out of these into HDFS, then you might use Storm, right, to sort of capture them in real time. So you can have a web interface. I have a cat, but it's basically your user over there trying to figure out what's going on out of all those things. So that gives you real-time analysis of what's happening. And then inside, you still have things like MapReduce, which is trying to give results. So it's counting the number of people with glasses on. And then Pig, because people hate using Java, is a scripting language. As a joke this morning, I suggested, anybody know who Rob is? Robert? No, okay. So he was saying that he counted the number of times the FBI in their speech said the words like Snowden, or said children, because he's saying, like, if I do a word count, which is the same thing as me counting the number of glasses in here. If I do a word count, I can prove the FBI is being Orwellian. So I suggested we should do this for all FBI speeches ever, and then see if we can do a trend analysis to see if they're being Orwellian over time. This speech might have been less Orwellian than 80% of the other Orwellian speeches they'd given. You know, he's doing a point-in-time analysis of political theory. I want to do long-term, like, trend analysis of political theory. So PIG, as getting back to the point, is the scripting language, so I suggested we do a PIG word count, being a double entendre, PIG word count. All right, that was a great joke. So, that was a long joke. So Uzi is an orchestration system that's basically going to help you manage your MapReduce and your PIG, because not only is it hard to write Java and deal with HBase, so you write PIG Latin, it's actually called PIG Latin instead, but then you might get tired of doing it by hand, so you have Uzi schedule it for you, which is like every time something new comes in, every time the call center picks up a call, it flags, and so Uzi figures out, okay, I should run the script to update my results. So now you're doing big data analysis in real time using all these pieces. Oh my God, how do you log this, right? You got to keep track of everything happening all over. And if you're looking for risk, it's like you got to look all over. And then on top of that, people start to add old databases too. This is a recent graduate, real story, came in, was fresh off the boat and said, I want to have access to that HDFS environment. Great, you're really smart. So here's a SQL interface, and she did a drop table and destroyed the entire HDFS database. It took them 96 hours to restore the data because there's so much data in that database. And so Hadoop saves a lot of time unless you destroy it, and then it actually adds a lot of time. It can slow you down quite a bit. So controls are important. So as a final point, what's happening is you're getting these, this is the pivotal distribution. What you're getting is all the green represents add-on services, which is again like sort of the antivirus model. It's like after Microsoft gives you your operating system, on top of that you're going to add stuff. So you have Command Center, you have better SQL engines, and they have better logging. Command Center gives you the ability to, like, if people come in, you can keystroke log all their access. You've built a perimeter essentially around your environment by using a distribution if it has the right mindset. All right, so access control. Yarn authorization is interesting. So Yarn is a new version of MapReduce. Anybody know Yarn? Familiar with Yarn? Not a responsive audience? If I give you a certificate to Amazon for 50 pounds, will you say you have used Yarn? Okay. So I do actually have a couple gift certificates, but we'll get to that later. So Yarn authorization is funny because you see the top level, it says everyone star. You see how no one is space, right? Try auditing for space. So look at the level where it says users and no groups. So if you want to actually authorize users and not groups, you put your username and a space. But if you put comma space, that's okay, because that would be your next user. But space means no group, right? Awesome. So groups, no users would be space, then group. Because if there's a space before the group name, then there can't be a user. But if it's a comma space, then it would be a user, not a not user. All right, so with that in mind, if you go into these environments, Hadoop environments, you'll find a lot of times that they put star in a lot. And the reason they put star in is because they say you have to. It's the default setting, first of all, but you can't take star out of some jobs because they're random. It's like going to Gmail or Yahoo Mail. You can't basically access control list them because everybody has access to Yahoo Mail so they can get their mail. You can't predict who's going to come in and check their mail unless you have an access control list of every user. 2 billion users is not going to happen. So instead, what do? You give them a secret or a token, right? If I know my secret, I can get into my mail account. So this is the theory behind Yarn. For certain jobs that are exploding, tens of thousands of jobs, you would have to have tokens distributed properly. But remember what I said about tokens before? It gets worse, all right? So I'll show you in a little bit in the next section how bad it is. But tokens basically can be delegated, or tokens can be used over and again, and they don't die. So if I'm depending on access control lists not working, star, because I can give tokens that are tied down, you basically just steal the tokens. You can go find things that are star access control, and you can get in forever. So other controls are really needed. Here's a good example of how perimeters are built. So in this model of access control, on the left is your ad hoc or your development environment, where you have users with accounts. You have tickets every time somebody logs in. They have to have a ticket. And then you get tickets that expire. So sounds good, right? On the right is your production environment, where you give batch accounts access. The tickets come from key tabs, and they auto-renew. So it's like the production environment is built to run forever, and the user development environment is meant to be locked down. Sound backwards? right? So it's interesting to me that you see this. You just don't want to slow down production because you're driving the car in the race. You want the rear view mirror, and you just don't want to slow down. So you've got everything for performance, scalability. So you turn off a lot of the controls you might have if it was just like your daughter learning to drive. All right, so authentication perimeters get pretty interesting. If you have your users and then you have your services, assuming you split these two and you want to give services infinite control, there are a lot of holes you can poke from the user layer into the service layer. So you can come in through SSH. We were able to kill Telnet off, yay us, but we weren't able to kill off HTTP. So people can come in through web HDFS without encryption. You get the password, then you can go in through SSH. There's an HDFS client that goes direct to storage. There's a MapReduce client. Basically, the idea here is you can get to any job tracker or name node. Name nodes are going to deal with your storage. So if you want to get access to storage, you would attack that. If you want to get access to jobs, you'd go after the tracker. So domain perimeters, this is one way we're trying to deal with it. You have an Active Directory domain in your company, and you build a perimeter inside Hadoop. So you would lock down the Hadoop environment, and then obviously you would share just a limited bit of information. If you don't exist inside, you can't log in, and we're going to share we're going to create a group, the Hadoop users. But of course, people can still SSH in directly if they get the credentials. If they know the HDFS username and credential, they can just come in directly, bypassing our perimeter to do work. And so we might put a Bastion host in the way and then force these guys to come into the Bastion host, which talks to the Active Directory. Now there's no way for them to get in. So these perimeters sound pretty cool. That's basically how we're trying to deal with it. But it's not different from the enterprise. I can let your imagination go wild. You can easily, that Bastion host being compromised, for example, you can collect all the credentials in a Hadoop environment. For all the users. So vulnerability management, another fun section. I'll go quickly. There are 3 CVEs known for Hadoop. Seems sort of shocking. 3 CVEs. I'll give Cloudera a little special credit because they have 3 of their own. So total, there's overlap. There's 5 total CVEs. How many vulnerabilities do you think there are if you search in the Jira of Hadoop? Jira is their bug tracking list. Any idea how many bugs there are? Vulnerabilities in Jira versus how many CVEs there are? I don't know. There's just so many. You almost need to run a Hadoop job on it. So here's an example of what I was talking about with a delegation token. This is a real vulnerability I found in the Jira. So delegation tokens show up in the URL. The URL gets written to log. The URL has your token in it. This is like one of those mistakes that amateur web programmers make where they put your token right into the URL and you just grab it and then you can just log in forever as that person. So the obvious solution is to do what everyone has been doing, which is hide it somewhere. Put it in the header. Put it somewhere where it doesn't end up in the logs. Put it somewhere where it doesn't get shared. Like, hey, go to this URL to log into my Hadoop cluster. And then they're already logged in as you. Right? There's no authentication required. Here's another example. Passwords and secrets are scattered throughout. A lot of the developers are like, I really want to use encryption, but we don't have a key management tool, so I'll just put the key next to the storage. That happens a lot. Or put it in the scripts. So you can dig around in the Jira and find exactly where to get the exploits. There's like a million vulnerabilities in there. I taught a class to some computer science students last week near Vienna, and I told them their grades would be based on how many CVEs they could file out of Jira. So hopefully there'll be a lot more soon. And if not, they're bad students. So yeah, I don't have a ton of time. So just very quickly, the idea that Netflix and others have propagated is that servers aren't pets because we're growing them so fast. You shouldn't hang on to them. You shouldn't treat them like, this cat, you're feeding it cake. Oh, my server's so lovely. I really think it's important and special. You should treat them like cows instead. But this was, I think, created by people who don't know anything about cows. I know a little bit, and I grew up around a lot of cows. And so it turns out that cows kind of are like pets, the operative word being asset, right? A pet is an asset because it gives you affection, I guess, or whatever. People have different reasons. But an animal like a cow that you have as a rancher gives you milk and money and cheese and whatever. So if you just look at it as an asset, then you will protect assets. And it turns out that we know a lot more about cows than we do pets because they're such valuable assets. So with that model, in 2012, I spoke about how to deal with cholera. This is a historic, I don't have a lot of time to go through it, but basically, if you look for a source of infection the way we do in cows now, and we can understand the propagation of the infection, then we can find the source and eliminate it, which was developed in the 1850s. It was the beginning of germ knowledge. It was early big data analysis, if you will, using math. This is a Voronoi chart. It proved that people that lived next to water that was contaminated died. That was the beginning of germ theory. It also proved that if they drank a lot of beer and didn't go to that water pump, then they didn't die. So beer saved people. So I apply this to technology, and basically ERM is if you can easily identify problems and have routine treatment and minimum judgment, then you're on the right path. So we need solutions like aspirin or ibuprofen or things that we've identified are really simple And that's how we're going to deal with vulnerabilities. But the only way it works is if we have on the back end some way of keeping records. So you identify the problems, you store those records. It's basically the big data analysis piece. So keeping them separate and understanding where resilience comes from really helps vulnerabilities. And so in a big data environment, these are examples of illness. These are vulnerabilities you run into. The HTTP services, you'll find job tickets, service delegation is broken. You'll find data node authority is too high. APIs can be easily abused. Kerberos has no definition of randomness. People freak out when randomness issues come up in hashing tables and talk about there's competitions to make sure that hashing is secure outside Hadoop. But inside Hadoop, nobody talks about at all whether or not the tickets generated by Kerberos are random enough or secure enough. So here's an example of where I would look for illness in a MapReduce job. A bunch of cows show up. All right, so data protection. Important thing to realize here is that there's really no reasonable expectation of privacy anymore once we start talking about massively distributed systems. This is a recent court case in California which says if the data is recorded somewhere, then that data is public information. So in that sense, how are you going to protect data that's considered public? It becomes sort of weird. If technology is merely capturing information that you knowingly expose, then it's basically public information. So it becomes a question of the expectation of challenging integrity, and it's sort of like a civil data disobedience exercise. And so as a quick example, radar is trusted almost implicitly in a lot of cases. So my brother, for example, went to challenge this in court, and having been an astrophysicist, he said, let me explain to you the mathematical algorithm that will show you that you've misfired your radar gun, and I'll help you improve the integrity of your radar guns if you let me out of this ticket. And they said, okay, guilty. So he was like, I can map worlds. And they're like, we don't care. So I got a ticket that was laser-based, and I was like, that seems strange. Maybe I can challenge, that's not going to work. I definitely can't challenge laser. But I can maybe challenge it the way I know as a social engineer. I can just go pay the judge, and he'll let me off. So that's what I did. I gave $75 to the son of a guy who went to law school with the judge, and magically it disappeared. But in the meantime, I learned that a laser is unable to detect moving objects. So even though there's a guy on the street firing a laser saying you were speeding, and I was going really fast, I'm not saying I wasn't speeding, but if they do that and they tell you that you're guilty, it turns out that they can't see you. That blank spot is basically what they see, which is birds, which is clouds. Anything moving is invisible to the LiDAR guns that they're using to tell you that you're guilty, which is so weird. They can see things like, they actually use LiDAR quite a bit for really interesting big data analysis. Like this is analysis of power lines. Can tell you if there's a break or tell you if there's a weakness or something, right? Can see the trees, can see everything. So this blankness, I think they should be called LiDAR, actually, honestly. And so I read actually recently in 2013 that all laser scanning methods basically assume that the object is stationary. That's 2013. And yet we've been for years, at least 20 years, I think, using LiDAR to detect moving objects. So yeah, data protection is weird. So it actually turns out, if you can't kill those viruses with medication, then you should just take out a lawsuit, because there's other ways of dealing with data protection errors. And so what we're starting to see is that issues of trust are coming around relationships. You protect things based on authority and relationship to one another. Some people say this is how you'll defeat things like ISIS, if you really understand the complexity of the relationships. So that's not very promising. But here's a real world example. Google has LiDAR on top of their cars, right? Their automobiles. I call them autos because, I don't know if you know, but automobile, the first time was automated, right? Mobile, automated. And since we're trying again, it's like the automated mobile. So the auto admits our failure, or auto 2.0. So the LiDAR sitting on top basically is supposed to detect stuff, but as I showed you, it's blind. So I've been thinking about ways that we can blind the LiDAR effectively and then blind the GPS by redirecting it, and so their cars would go out of control. So in that sort of big data environment, you have to worry about whether Google decides to send you off the road because it detects something and it thinks that it's right and you don't think it's right. For example, it detects a school bus with children in it and it says, I'm going to send you off a bridge because I need to save those school children. And you're like, there's no school bus, and they're sending you off the bridge. You're giving control to them. So data protection becomes weird if you give over control to people who are basing their decisions on faulty systems, which we knew way back to 1980. The United States had an operation in the desert that went awry because a guy was staring at somebody on the ground, and he was in a helicopter, and that person started walking, and he couldn't tell because of brownout conditions. So we've been developing a better technology for years in the military based on this idea. And we're fixing it now, some ways, examples of fixing it with a cumulo, which basically means if you want to compromise an accumulo environment, You see this little admin of a cumulo. If you can compromise the admin, then you get complete control. But you're basically locked out of the network now and the storage in a cumulo environment. Tahoe is another example where same thing. If you can get into the Tahoe gateway, which can run local, so it can be hard, but if you can compromise the gateway, you can get into the environments. It's the proxy which becomes the focal point of protecting data, as opposed to the network or the storage array. Those are our current solutions. So finally, network and system solution. There is a lot of encryption to protect the network and the systems, but it's not well deployed. So ask any Hadoop environment how they manage their certificates, or even ask them what are they doing about Heartbleed. It's not a popular topic inside Hadoop environments. They really don't have any idea. And so there are other more deeper problems, like there's no encryption for JDBC. Why does that matter? Hive, for example, SQL, anything that's SQL running on top of HDFS. So people that are trying to use Java queries into the storage are often using JDBC. And with no encryption, you just go and intercept a lot of that communication. Even more so, when they turn on SSL, anybody know what null ciphers are? Null ciphers, non-ciphers, no ciphers. So they turn on SSL, but in the documentation it says they're turning on null ciphers. It's the only thing that they support right now. So as you dig into communications that people are using to talk to get the storage, then you find more and more instances. I gave an example here of JDBC. This is what a typical JDBC call looks like from Hive, and there's no SSL, there's no encryption. You're basically doing clear text. So here's an example recently of MapR and Splunk got together and did a demo of how they're mining Twitter data. And right away I noticed they're doing it over a non-SSL connection. When I looked at the Netflix Security Monkey, again, no SSL connection. And Security Monkey is the management tool for security in a large distributed environment. And you're logging in as an administrator to your environment with no protection of your password. So it gets more and more complicated as you get into like larger environments. This is an example. RPC calls, HTTP, Avro, Thrift. So any one of these that has a credential gives you access into the environment, and you can pretty much pick and choose where you want to get in as you dig deeper. All right, so that's basically the whole idea. You have 6 things that I went through where there's lots of room for improvement. And then, of course, with GRC, we'd sort of see from a top level where things were breaking, which hopefully if our policies are set up right and our monitoring is set up right, we'd see, oh yeah, we have somebody doing strange behavior. In the beginning, I talked about an RSA solution, for example. It's really behavior-based. It's not just that there's somebody who's connecting over a port we haven't seen before, which is useful. For example, over the past 12 months, we've seen these JDBC connections, and they look like this. And now we're seeing a JDBC connection that looks different. It's at a different time of day. It's accessing more data than it used to. So if you build enough data points using big data analysis, you can look at big data systems and see unusual behavior. And so then you could say it's compliant or not. So the future state, essentially, very quickly, is we've made some progress with some distributions. So I haven't put names on these, but they've come up with their own, this is my fear, they've come up with their own security, like as if we've never done security before. And I don't know anybody who wants to do an ADPV or a PAAE compliance check. They even use the word perimeter in their model, which I think is ridiculous. We're trying to get rid of perimeters, and they're like, you can build a perimeter. These guys use encryption in their model, which I also don't like. And then we have these other sort of side projects that are supposed to take care of everything. So I think what we need to do is build something more like the 6. And I'll tell you the truth. I borrowed those 6 from a bunch of compliance standards that I looked at, and I thought, well, we've done these before. Why don't we just apply these to Hadoop? And that'll make people happy, because once they're done, we can just say they're also compliant with HIPAA and PCI and other stuff. So here's a quick 4 phases or 5 phases of how you do it in the future. Basically, remember the latency argument? Remember all the arguments about how scalability was supposed to work? This is what it used to look like. You had a bunch of distributed systems, and you had a checkpoint. And that turned out to be not so secure, so we moved everything into a data services layer. And we have really fast network speeds, so the latency is an issue. So your compute that's distributed actually becomes just memory and chip. There's no storage on the nodes. It actually is centrally. Why is that cool? Because if you centrally store the data, then you can have access controls on the data based on classification. So if you know Bob shouldn't see Alice's home data, they should only share work data, then I can actually build an access control list based on authority on the data. And this is a real architecture that we're starting to use, which is every time someone queries a big data environment, I check to see if they have access to it. But I can do that because I have it centralized. If I have it distributed, it's literally like asking every one of you every time somebody wants access to data, whether that person should have access to data. It gets really complicated. Distributed systems are very difficult to engineer. But if I centralize it in a distributed environment, then at least I have a stopgap. It's like building a perimeter using fast enough speed. And so then I can provide some least authority, like I talked about accumulo and laughs. Then I can provide some way of saying, if I give you access, my grant of access isn't just like an ACL. It's not just saying your name gives you access, I give you a key. So now every time I give somebody access, it comes with a key. And so when they say I'd like to access this file, they show up with a token. Now your access controls can be opened because they come with the security of the token or the ticket. And that actually works. So real world examples, we can have an environment, a service layer essentially. So when somebody tries to do Hadoop-like stuff, they talk to our proxy, they talk to our service layer, and we would check to see if they have access or not to data and compute resources. Both are scalable. And then in a real world environment, here's a hospital. So outpatient, inpatient care would go to the service layer to try to query what status is, and then all the stuff going on, like insurance companies trying to do analysis and different parts of the hospital doing work, would be feeding into this data lake. So we create a buffer essentially, and so that's where we are today. If you don't do this, then you try to distribute the security throughout everything, and it's just like Swiss cheese. It's like people can walk through basically anywhere. It's shooting fish in a barrel, as we say. So that's basically the whole talk. Within an hour, there was a lot to cover. I didn't get to go into too much depth, but that's again why I'm trying to build transparency, show everybody where the risks are, trying to show that the tools that are relevant are different than what we might have done in the past, and then show that resilience really has become one of the most important pieces. Because if these systems die, like when that intern killed 96 hours worth of data, I see all the time the executives say, okay, I'm done with Hadoop. If you can't keep this thing up, then forget it. Just get off it, go back to Oracle or something crazy. So, all right, thanks a lot for your time, and I'll take questions. I'll pay you for your questions. I would be giving you a book, but I didn't carry them. They're too heavy. I do sometimes give away the book. Yeah, the new book will be out in a couple months, hopefully, so which covers all of this stuff in more depth. Any questions?
You mentioned that, let's go back to Oracle. Are Oracle planning to bring out products similar to Hadoop that are better designed, or is it just Oracle, let's go back to the old standard database?
I would never want to answer for Oracle, but I can guess. So the question is Oracle planning to do? Yeah, so my theory is, overall, we're moving away from databases because databases were structured in a way that was limiting, and people want access to unstructured, so you can do databases on the fly. So I believe that the databases will become a front end to the actual data repositories, and as people shift to a new mindset, they'll move off old database-like management interfaces. Like I will access my data through my Oracle database. They'll move to direct access, streaming access. So for example, on the Twitter, everybody uses Twitter, but if you look at Twitter followers or URLs that are getting picked up, if you did that in a database, you'd be extracting and dumping. It's ETL, right? You extract, you do transactions, you load. So you try to move away from that and do like real-time queries. Like what's the most number of followers now? Now how many people are following? Now how many people are following? So the future is probably getting to real-time. But I'm not a database guy, honestly. I'm just an old pen tester. So whatever they do, I'm looking for flaws. Yeah, there is a gap there because they have to have access and credentials. And the more you use an intermediary that isn't secure, the more you open yourself to people also having access to the intermediary, the gateway. If I can compromise the thing in the middle, then I can go and do whatever you can do, impersonate you. Yeah, that's why we want to build a secure gateway where you can't get in unless we really test you for proper credentials. And ideally, it would be, back to my Ebola example, it would be we don't actually have to build an all-knowing, all-encompassing system because we have a way of asking people to, in a hierarchical way, go and ask people that they know who ask people that they know, and only things that are important get reported up through the chain. So we don't have to know inside of certain environments. And that's for an IoT model. If I have an engine with 30,000 sensors, I don't want to go in and listen to every engine all the time, everywhere. I want to have engines that are able to identify flaws, report up just that flaw data. It's the same argument as, do I want to have development environments in information mode or debug mode, or do I want to have them in warning mode? So you want to turn things into warning mode, but still have the ability for things inside to know what's important enough to report back. It actually turns into political science more than computer science because of privacy issues. Any other questions? 50 pounds. That's sad. I can't pay people for a question. Anything. Where did I make the suit? Yes?
When you make it so unauthentic, what's one security incident that you've seen,
What's that?
have you seen any specific security incident?
Oh, have I seen a security incident? So, well, I mentioned one with the woman who destroyed the data. What can I say? Yeah, I've seen outages, basically. Availability has been the biggest incident because we measure that. A theft of data, we don't really even know yet how to measure that properly. We have some environments that are PCI compliant. We have some that are HIPAA compliant that are getting there. But honestly, the incidents that show up easiest and most are availability because they're so easy to measure. If you still consider that part of security, which I do. So, yes. Yeah.
Has anyone done anything with
Custom computing in Hadoop?
Trust?
Oh, trusted computing in Hadoop. No, not that I know of. Well, actually, I should take that back. So one of the things that runs on Hadoop is like the NSA. And so large intelligence gathering organizations probably do trusted compute just because they still have that stuff sitting around. They haven't migrated off yet. But I think more to the point, it's a commodity architecture, and trusted tends to be expensive. And so people are pushing ahead so fast onto cheap, easy, they don't want to put in place something trusted. However, Intel is, I think, banking on the fact that they're going to make secure chips with crypto accelerators and I don't know, HSMs, and they'll put those into every node in a big data environment. This is the norm for data management in a few years. So every Intel-based node may have the ability to be a trusted node. So I see that coming in the next year to 2 years. We'll start talking about how to talk to an HSM on a node. Yeah. Yeah, I didn't say that I have it. Yeah. Somebody has claimed to have a Hadoop environment that is PCI compliant. And the ones that I've seen, they're, the scoop flume relationship, they're mostly scooping, so they're out of date. So they basically scoop into an environment that's heavily locked down, that has sensitive data, and that gets out of sync. It violates the idea of real time, but it's the only way to lock it down. And only so many people, and they use a bastion host. So if you go in, it's key logged, so they can go backwards in time. Yeah. So it's compromised. Nobody that I know of is doing a true wide open Hadoop environment with PCI compliance. I think the closest you could get with Accumulo would be okay. I think Tahoe Laughs may be even better, where you're encrypting every cell and you're encrypting access. So it'd be pretty heavy, complicated. But we're working on building that as a model, because that's where we have to go. Any other questions? Saw another question out there. Now I have too many questions. Who wants the certificate? You have to fight it out. One more question. Can't go unless you ask another question. Yeah.
What do you see as not Hadoop related, but Internet of Things related, what do you see as a future challenge for security in Internet of Things?
So I've mentioned that. The future of Internet of Things security is building these pockets where the things can talk to each other and only report important enough information back out. So we need a way of designing a model. So your home, for example, is your private barrier, but I can get data out of your home that's relevant to fixing your systems. Like a vulnerability is on your systems. I only need to know that you have a system that needs a patch. I don't need to know that you were home between these hours and that you had a girlfriend and not your wife at home with you. And I don't need to know that you haven't paid your bills or that a known felon is in your house and I find that out by tracking them inside your home. So there are all sorts of privacy issues around things that we need to build pockets. And I don't see a lot of people actively building those pockets and reporting ACI ways of communicating yet. So that to me is the problem. APIs should be able to give us some privacy and some, who's actually leading this is some of the SaaS providers. Because SaaS providers give you the ability to get services, but you can't see inside them. They're hiding a lot. They're hiding a lot of really bad behavior. They're not patching, they're not protecting your data, but you can't see that because they've created a SaaS layer. But your API says my data is my data and I can't see anyone else's data because I'm using the API, not because I'm looking at the actual access controls on the systems behind the API. So strangely enough, in the model of the SaaS, if we use the SaaS model in our home, then we basically flip everything upside down. Google is our customer, we're the service provider, we're giving them access to us, but they can't see inside, they just get what access to, we give them an our API that we turn on. Yeah, that's the challenge of Internet of Things. And it's in the tens of thousands of nodes per person, not in the wearable discussion is like 8, 9, maybe 15 devices. And I'm talking about tens of thousands of devices, which is the industrial Internet of Things, much more complicated than the wearables. All right, thank you.